Honors Algebra 2, Chapter 5. We're going to do Section 5 and 6 here. We're going to first divide polynomials. And we did synthetic division yesterday. And today we're going to look at long division. So let's first review what long division is. So we just take some number. So 2, 4, 7, 5. And I'm just making up numbers here. So 247,532. And we want to divide it by, let's say, 22. So now the process to go through here is we want to look at how many times does 22 go into the first number. Well, it doesn't. It goes in there 0 times. How many 22s go into 24? Well, 1 does. So I do 1 times 22. I get 22, and then I subtract. And so then I get 2. Drop the next number, 27. And we repeat this process, and this is how you long divide. This is what we did with numbers back in like 6th grade. So then 22, how many times do those go into 27? It goes in there 1 time again. So we have 22, subtract, we have 5 left over, drop the next number, so we have 55. So how many 22s fit into 55? That'd be 2. So 2 times 22 is 44. Subtract here, and we have 11 left over. Drop the next number, we have 3 left over. So then how many times does 22 go into 113? So that'd be 5. So 5 times 22 would be 110. Subtract, we have 30 left over. And drop the next number. Oh, we have 3 left over. Sorry, we have 3 left over. Drop the next number. We have 32. So we have 32 here. And then, so how many times is 22 going to 32? 1 time. 1 times 22 is 22. Subtract. We have 10 left over. This is our remainder. There's no more numbers. Now, we could keep going by having like decimals, like point. We can keep adding as many decimals as we need. So like we could add another 0 there, and we can keep going with the decimals. For the sake of the problem that we're going to be dealing with, we're not going to look at decimals. Let's look at the remainder. So we had 10 left over. We can write this as a remainder of 10. So we write our answer. It's going to be 11,251, and our remainder is 10, and we're dividing it by 22 still. So we can reduce that fraction, divide them both by 2, and you get 5/11ths. So this would be the final answer. So you do 247,532 divided by 22, you get 11,251 and 5/11ths. And so that's the process of long division. I want to show that because we're going to do the same thing, but we're going to long divide polynomials. So some of the definitions first. When we are dividing here, so we have, we're taking some kind of value and dividing it. We have the dividend f, and it's being divided by the divisor d. So these definitions, do you know what they are? Can you explain those? So we're taking some dividend divided by the divisor, and that's going to equal the quotient plus the remainder divided by the divisor. And so that's kind of the process to go. And so that's kind of the process to go through to divide, kind of what these terms are called. If we're going to long divide these two values, when we are writing that, we're taking x plus 1 and we're dividing it into the polynomial x squared. Now, we don't have an x term. We need to include that though, plus 0x minus 1. So right here it just says x squared minus 1, but we have to write x squared plus 0x minus 1. And then we can go through and actually long divide here. So the process to go through is here we're going to actually take x times what value is x squared. And so go from x to x squared, we need to multiply by an x. And so then I'm going to actually multiply this entire binomial by the x. If I do that, I get x squared plus x. I'm then going to subtract the two values here. So x squared minus x is 0. That's what we need to happen. This term with the biggest degree becomes 0 there. And then 0x minus x is negative x. Drop the next number, negative 1. So it's the same process as long dividing numbers. We just have to do it with multiple terms. So now we have negative x minus 1. So x plus 1 times what is negative x minus 1? Or x times what is negative x? Well, just negative 1. So I multiply negative 1 times x is negative x. Negative 1 times 1 is negative 1. We are subtracting these again, so negative x minus a negative x is 0. And a negative 1 minus negative 1 is 0. So we don't have a remainder here at all. This divides evenly. So x minus 1 is the quotient, the answer we get from dividing x squared minus 1 and x plus 1. A little more complicated here. Now we have this degree 4 polynomial and we're dividing it by a trinomial. So again, we put the divisor x squared plus x minus 1, and then the dividend inside here, 6x to the 4th minus x to the 3rd minus x squared plus 9x minus 3. And so what do we multiply x squared by to get 6x to the 4th? And so your export rules come into it. So we can write like 6x to the 4th divided by x squared, and we get 6x squared. So that's what we need to multiply by. When I write that, I'm going to write above the x squares. So it kind of organizes our terms. So now I'm going to multiply this trinomial times 6x squared. I'm going to get 6x to the 4th. And then 6x squared times x is going to be plus 6x cubed. And then 6x squared times negative 1 is negative 6x squared. I'm then going to subtract these terms. So we have a negative x cubed minus 6x cubed, so we have negative 7x cubed. And then negative x squared minus a negative 6x squared is positive 5x squared. We can drop the next term down, which is plus 9x, and then repeat that process. So x squared times a negative 7x squared, or x, is going to be x cubed. So we have x squared times negative 7x. So I'm going to multiply this trinomial by negative 7x. If I do that, I get negative 7x cubed minus 7x squared, and then positive 7x. Subtract these, I get 0, and I'm going to get 12x squared, and then 9 minus 7, so positive 2x. Drop the next number, and one last time. So x squared times 12x squared, x squared times 12 is going to be 12x squared. It's going to multiply by 12. So distribute, I get 12x squared plus 12x minus 12. Subtract, I'm going to get negative 10x, negative 3 plus 12, so positive 9. This right here is our remainder. There's nothing else to drop down. So then we're going to have plus, or actually I could, you have a plus negative 10. Get rid of this. 10x plus 9 divided by our divisor, the x squared plus x minus 1. So this will be the final answer. So that's long dividing. And so we have to use long dividing when we are dividing by trinomials or like binomials that have these leading coefficients in this form. You need to use some long division. So it's the only method that always works for dividing. Synthetic division is nice when we have binomials like this. Just use the synthetic divide by 2. Let's look at 5, 6 functions. We actually already talked about this, how we have our zeros of 2 and negative 6, and how these are the x-intercepts, roots, zeros, solutions, factors. They all mean the same thing. And so we can look at these factors. We can find the zeros or roots or solutions, and we can plot them as x-intercepts to help us graph. We did that a couple of days ago, the exact same problems. And so we can take these binomials and we can plot them on here and get a sketch. We already did that problem. What we're going to do is we're going to look at how to solve it. So we can use the graph to help us solve it. So when we look at the graph of this polynomial, we're trying to solve it, which means we're trying to find these x-intercepts. Well, when we look at this graph, I can see that it crosses at 2 and 4. Those are two whole numbers. I'm not quite sure about this last one. This last one might be some decimal. I can make some estimates or some guesses, but we're not quite positive. But by looking at the graph, we know that 2 and 4 should be zeros. And so we can synthetic divide by those to see if they are zeros. So we take these zeros and we're going to synthetic divide by them. So let's write our coefficients first. So we're taking the coefficients of our polynomial and synthetic divide by any of the zeros. Let's choose the 2, the smaller one. So drop the -3, multiply, add, multiply, 28, add, so we have -8. And then multiply 2 times -8, get -16. So we have 0 there, no remainder. So we're going to repeat that same process. We're actually going to take the other 0, 4, and we're going to synthetic divide our solution by the other 0. So it's like double synthetic division. So drop the -3, multiply, add, multiply, add. Notice how we get another 0. So what's left over is just this quantity here, which really is the 2 is the constant, -3 is the x value. So -3x plus 2 is what would be left over if we took out the factors of the x minus 2 and x minus 4, or these zeros. So if I set this factor equal to 0, I can find the rest of the solutions. So -3x equals -2 if I subtract 2 to both sides. Then divide by -3, so x is 2/3. So that would be the last solution. So now I know it's crossing here at 2/3, or 0.6 repeating. Now, if you divide by one of these zeros, you could have used the quadratic answer and factor a quadratic formula to find the other solution. But if we know two of them, might as well do the double synthetic division to help us get down to a linear factor right here that we can just solve. Once you get it, you should check your answer to make sure that it seems logical with what the graph is stating. Let's have this one be your homework problem. I'll try the other one. So complete this one. So you need to look at the graph, find the zeros, synthetic divide, and then find the other zeros. And your synthetic division is kind of proof that these values are zeros, that you find the zeros. For the other question down here, there's only one x-intercept here, 2. It's at x equals 2. So let's synthetic divide this by 2. Drop 3, multiply, -4, multiply, -8. Add 2, multiply 4, we have a remainder 0. So we're left over with 3x squared minus 4x plus 2. And now we need to find zeros of this. And so we have to use our logic or our knowledge of our previous unit of how to find zeros of this. We could use complete the squares, but kind of tough because our value is 3. We could try factoring, but factoring is not going to work here. So let's just go to quadratic formula. So x equals opposite b, plus or minus the square root of b squared, which would be 16, minus 4 times a, which is 3, times c, which is 2, all over double a, which is 6. So this is 4 plus or minus the square root of 4 times 3 times 2 is 24. So we're going to get a -8 all over 6. And so I could write this as 2/3 plus or minus I root, because square root of 8 is 2 times root 2. So I have I root 2 over 3. If you need to see that work, you take like the square root of -8 and you write that as 2 root -2 or 2I root 2, and then you can reduce this 2 with the 6 in the denominator. So this would be the other two solutions. They're imaginary, they're non-reals, which makes sense for the problem because notice how this turning point never crosses the x-axis, so it doesn't give us an intercept, so it gives us the imaginary solutions. And so I want you to do the same thing with the previous problem here, finding the zeros. So you're synthetic dividing. You can do it twice, great. If you can only do it once, then you use your quadratic knowledge to find all the zeros. Our degree here is 3, so we should have 3 zeros. call it good for the night. So have a good night. See you tomorrow.